Okay, let's start talking about long division of polynomials. Before I do that, let's just chat for a second about long division of whole numbers here. Suppose I had 137 divided by 9. If you remember the algorithm or the procedure for doing that, you would put what? The dividend, that's the numerator, in what we call the doghouse here, right? The 137, and then you put the 9 over on the left-hand side. That's the divisor or the denominator. Okay, and then you would go 1 goes into 9 0 times, 1 goes into 13 1 time, so you go like that, and then 1 times 9 is 9, and you would subtract, and you would get 13 minus 9 is 4, and bring down the 7, and then you'd start dividing again here. 9 goes into 45 or 47 5 times, because 5 times 9 is 45, and then at the end you've got a remainder which is 2. Okay, 9 doesn't divide 2 at all, so there we go. We would say the quotient up here on top of the doghouse. All right, you remember this is called the quotient. Okay, and then you'd have this is the remainder, right? And usually you want your remainder to be less than your divisor. Okay, for example, if I'm dividing by 9, I usually don't stop with a remainder of 17 or something, because there's a 9 in there, right? Okay, a way of rewriting this or restating this is that 137 is 9 times the quotient plus the 2 left over. Okay, so you remember this from basic arithmetic. Now, we're going to do something very similar here when we talk about long division of polynomials here. Okay, I'm going to assume p of x and d of x are non-zero polynomials. Then I claim there exists, I guess there should be a comma there, then there exist unique polynomials, okay? So they're one of a kind here. Unique polynomials q of x and r of x such that p of x is q of x times d of x plus r of x. Here's my little proviso here. To get uniqueness, the degree of r of x has to be strictly less than the degree of d of x. Now this d of x is going to be my divisor. Okay, it's actually a polynomial. That's why I show the x dependence there, at least in general. Q of x is going to be my quotient. Okay, and then r of x, what I'm calling cap r of x there, is the remainder. Okay, so I claim we can always end up doing this, and I'm going to show you a procedure similar to long division of whole numbers that we shall end up using, okay, to find the quotient and the remainder, and we'll talk about ways we express our answers. Okay, let's come over here. Let's take our first example here. Okay, I've got x cubed plus 8x squared minus 15x minus 13 divided by x minus 2. Now, if the problem is messed up so that these are not in descending order, okay, the numerator and denominator, or the dividend and the divisor, if you wish, you like that terminology, write them in descending order first, okay? And this doesn't apply in this problem, but it will in the next one here. Include any missing terms on the dividend, okay, the numerator, okay? Now that's going to, just like dividing long division of whole numbers, the numerator is going to go in the doghouse, and the divisor, or the denominator, is going to be out here on the left-hand side. Okay? Now I have to think about how I start my division. Okay? The quotient that you're going to end up with is going to be right on top of the doghouse, just like we had in the case of what? Long division of numbers here, too. So the analogies are very apt here. Okay, now here's what we're going to do. How do you start out? Well, it's very simple. Just consider the first monomial terms that appear in each of the polynomials you're dealing with. Okay, so forget everything else right now. Just think of x cubed divided by x. Now think in your head, what is x cubed divided by x? Why, it's x squared, right? You can do that in your head. I claim that x squared is going to be the very first term in your q of x. That is your quotient. Now, where am I going to write that x squared? Like I said, I'm going to be writing the terms of the quotient on top of the doghouse here. Where am I going to put x squared, do you think? Well, I'm thinking about right above the x squared here in the dividend. So I'll go x squared. That's the very first term in my quotient. Okay, we've got a lot more work to do here, but let's go back. Where do I go from here? Well, just like I did in this division problem, I took the very first term in my quotient here, and I multiplied it on what? The divisor, wrote that underneath, and then subtracted. It was important here. Remember, I'm subtracting. Okay? All right, now I'm going to do the same thing here. Now, x squared is going to multiply on the x minus 2. So let's do it term by term. X squared times the x gives you x cubed. X squared multiplies on the minus 2x, becomes minus 2x squared. Okay, I'm going to draw that little horizontal line there just to separate things. And out here, like I was doing in a previous video, I'm going to remind myself that I'm subtracting. That is not attached to any particular term. I'm just going to remind myself that I'm subtracting as I go through. Now, x cubed minus x cubed is 0, so I'm not going to write anything there. Okay, I'm not going to write anything. Okay, because it's not going to do me any good. Okay, 8 minus negative 2, x squared, right? Okay, it would actually be positive 10 x squared. Okay, that's actually 10x squared. Now, I'm going to bring down the rest of the dividend polynomial, so the minus 15x and the minus 13. And now I claim this is my remainder so far. It's not my final remainder because what? The degree of this is too high. It's higher than the degree of the divisor. Again, just like right when we reach this stage, I took 47 and divided it by 9, right? Well, now I'm going to use this as my new dividend. So I'm going 10x squared minus 15x minus 13 divided by x minus 2. How did we do that previously? How did we get the x squared up here? We took the highest power term, right? Okay, the highest degree term here, which should be the leading term if you're writing in descending order. Okay, 10x squared, ignore anything else. Leading term here, x. What's 10x squared divided by x? Why, it is what? Plus 10x. By the way, I've seen students do this before here, just write 10x. No, this is actually what? These are the terms of the quotient up here. They have to be connected with operations, right? Do you see that's actually a plus sign there? So it's actually up there, x squared plus 10x. Okay, now 10x, do the same thing again like we were before. 10x is going to multiply on the terms here of the divisor. 10x times x is x squared. 10x times the minus 2 is minus 20x. And once again, I'm subtracting, so there's my little reminder. Notice I'm setting this up at each stage so that I get cancellation here. I get 0x squared here, so I'm not going to write it. Now, one of the biggest problems students have in messing up problems like this is what? Messing up their signed arithmetic. So be careful here. I've got negative 15 minus negative 20. The double negative here actually acts like a positive 20, right? So I've got negative 15 plus 20 is positive 5. I'm not going to put a plus sign there, though. Don't forget the x's on there. So I got really 5x. Bring down the 13. And once again, I'm not ready to stop yet because this is a degree 1 polynomial. Here, this is also a degree polynomial. My remainder does not yet have a degree which is strictly less than the degree of the divisor, so I've got to keep going. Okay, so we keep going again. Remember how it works? I take the highest power term here, which is what? Forget everything else, the 5x divided by the highest power term here, forgetting everything else. 5x divided by x is 5. That's plus 5, right? Okay, notice the terms up here in my quotient are in descending order naturally. Okay, I'm getting the answer up at the top for the quotient. Now multiply with a 5 like we were doing before. Okay, the 5 times the negative 2 is negative 10. Like always, what do? We subtract. Okay, the 5x's will cancel because I set it up precisely that way. Negative 13 minus negative 10 is negative 13 plus 10 is negative 3. Now, is this my final remainder? The answer is yes, indeed. The degree of this polynomial is what? Degree 0. 0 is strictly less than 1, which is the degree of my divisor. So I'm done. This is my remainder, and there's my quotient. I could write it this way if somebody explicitly asked me to write the quotient and remainder. Okay, I could do that. Maybe let's put a colon here or something. R of x, okay, is actually a polynomial of degree 0, so it's actually a constant polynomial, right? There's no actual x dependence, but there is in general, so I'll go ahead and retain that x there, at least for now, okay? But there's my R of x. Okay, what's another way of expressing our answer? Some people might do this. They might write this, our original x cubed plus 8x squared minus 15x minus 13 over x minus 2 is x squared plus 10x plus 5. I'm going to use parentheses here. Plus my remainder, negative 3 over my divisor, which was what? X minus 2. Okay? Maybe a better way of writing that would be what? X squared plus 10x plus 5 minus 3 over x minus 2. Okay? Sometimes I like to retain those parentheses at the end. This would be my final answer. Okay? In most situations, that would be the answer here, the form of the answer here would be equivalent to saying this, in this situation, back with numbers, that it's 15 plus 2/9. Okay? 15 and 2/9 for the answer. Okay? Remember with mixed numbers, that plus is often not present. Okay? But in this stuff, we better make it present. Otherwise, it looks like you're multiplying, right? Okay? Everybody got it? So there's the answer to that question. Let's go ahead and look at a second example. Okay? And I'm going to show you here in the second example. Now, everything's in descending order, so that's all good. Okay, here's my dividend. It's going to be going in here. Let's maybe put this guy out here first. Okay, so there's the divisor. Now, this is in descending order. You notice that there's a missing cubic term or third degree term here. I want to put that in there. It's going to be an important placeholder, so put it in. Okay? It doesn't matter so much if there's a missing one out here. You can space things properly and it won't be a problem. But if you have that missing there, it can be a problem if you're trying to stack things that are like terms. Okay? So here's the thing. If it goes in the doghouse, you better have the missing terms, right? Okay, there it is. Everything's in descending order again, like I said. Okay, now, remember how to divide? Okay, what do you do? Forget everything else except for the leading terms, right? The highest power monomial terms. So that's 2x to the fourth divided by x squared. That would be what? 2x squared. Where do we write the 2x squared? Oh, here's a good convention. Let's write it right there above the squares right here. We get that match up there. Okay, so it's 2x squared. And then what do? We take that term, the first term of the quotient, and we multiply it on the divisor. That means it's going to have to multiply in every single term of that divisor. So this is what we end up getting here. And if we've done this right, when we subtract here, we should have like terms beneath each other for easy subtraction. Keep track of everything easily. Once again, these are going to drop out, right? I've got 0 minus 2 is negative 2x cubed. Wasn't that convenient having that 0x cubed there? Yes, it was. 9 minus 2 was 7, x squared, and I'm going to bring down the rest of this stuff. And now we have to keep going, right? We have a remainder that has a degree that's still too large here. Okay, now let's start over again. Okay, so I've got negative 2x cubed divided by x squared. That's what? Negative 2x. Now multiply with negative 2x everywhere. Negative 2x cubed minus 2x squared minus 2x. Don't forget you're subtracting. So this should be pretty easy. I get 0 here. I get what? 9 here. I get 9 here. And I get 15 here and on the x and 15 here also. Okay? All right. All right. Now, let's keep going. This is a square, okay? All right. Degree here is the second degree. This is second degree. Okay, divide, you get 9. You get 9x squared plus 9x plus 9. Go ahead and subtract these. And you get 6x plus 6, it looks like. Okay, this has degree 1, this has degree 2, so you're done here. So what's going to be the answer to our problem here? It's going to be 2x squared minus 2x plus 9 plus your remainder, I'll use parentheses here, 6x plus 6, I hope I did my arithmetic correctly, over x squared plus x plus 1, box in your final answer. Okay, and there you go. Okay, so not too bad. You just got to be careful about the signed arithmetic here. Okay, I hope I did everything right. All right, let's do one more here. Okay, there's going to be a bunch of missing terms on this one. X to the fourth plus 0x cubed plus 0x squared plus 0x plus 4. Okay, I may not need all these missing terms in the end, as we'll see, but you never know ahead of time. So go ahead and include all of them, and we'll see here. Okay, now start out. X to the fourth divided by x squared is x squared, right? Write that up top, right above there. Multiply by the x squared, we get x to the fourth plus 2x squared. Don't forget we're subtracting. Okay, this zeroes out. This zeroes out, right? We really didn't need this missing term, but maybe we wouldn't see that ahead of time. So we'll go ahead and say, well, we didn't really waste our time in that sense. 0 minus 2 is negative 2. X squared plus 0x plus 4. You're probably seeing ahead of time here that that's actually what? That's going to be useless in this situation here. But keep going anyway. Okay? Negative 2x squared divided by x squared is negative 2. That's going to be over here, isn't it? I'm going to put it right above the constant term in this case. Notice that our quotient has a missing term. Okay, but that's okay. Negative 2x squared. Okay, negative 4. That's not positive 4, that's negative 4. And then we're subtracting. So we get cancellation. Cancellation, we get what? A remainder of 8. So our answer would have been what? X squared minus 2 plus, let's see, our remainder, 8 over x squared plus 2. And there's our final answer. Okay? There's the quotient, remainder, if somebody asks you explicitly about those, but usually I'm going to have the answers expressed this way. Okay, so there's some problems in the homework for you to practice on, and there we are. Okay.